Hello, so our group is Rotten Banana. So for our group members, we have the Aaron and also me, Chonghui, Sunwei, and also Xiaoming. So today we had do a Q&A session for our five moves. So for the five moves, I will discussion about the first move and also the second moves. Okay, so for the first move, it will be the electronic combos. So ECB mode is the simplest mode of the operation for the block ciphers. So it will encrypt each block of the plaintext independent using the same encryptor keys, and ciphertext of each block is entirely determined by the plaintext and the key, making ECB straightforward to implement. However, its simplicity comes with significant drawbacks, particularly its inability to observe patterns in the data. So identical plaintext blocks product identical cipher blocks, which can reserve repetitive structure. So it will be making it unsuitable for many applications, especially those involve large or structured datasets. So for the next mode is the CTR mode. CTR mode is a widely used and versatile mode of operations for the block ciphers. Unlike ECB, it does not directly encrypt plaintext blocks. Instead, it will be generate a key string by explaining unequal counters, and then AOS this key string with the plaintext to produce ciphertext. The counter ensures that each block is processed unequally, preventing the repeating of the patterns. Its ability to the parallelize bond accretion integration makes its particularly suitable for the high performance applications. So for next method.
Okay, now so I'm Desmond. So now I will introduce the CBC, which is cipher block changing. So the CBC is a mode of operation for block cipher that ensures strong encryption by aiding dependency between blocks. So the advantages of CBC is it will produce a unique ciphertext for identical plain text by using a random initialization vector, making it resistant to pattern detection. And the second is the changing mechanism increase the security as each block depends on the previous one, making it harder to decrypt without the full ciphertext. So it will also encrypt of each block relying on the previous ciphertext block. This ensures security, but makes parallel encryption impossible. So the error only affect the current and the next block. So it will limiting the impact. So I think CBC is secure and efficient for sequential encryption, but requires careful handling of the initialization vector and is slower for parallel tasks. And it perfect for application needing strong security. So how about you, Songmei?
Okay, I'm Cha Man. So I'm going to introduce the cipher feedback. So cipher feedback is a block cipher mode of operation that offers unique security features through its use of an initialization vector for producing different ciphertext outputs even for identical plaintext inputs. Though this requires the for to be random and unpredictable, the mode implements a feedback mechanism where previous ciphertext blocks create strong cryptographic chaining dependencies, causing an avalanche effect where small changes propagate through subsequent blocks, enhancing security but preventing parallel processing and potentially increasing processing time for large dataset. While CFB offers stream-oriented capabilities by processing data in units smaller than the full block size, its error propagation characteristics present a trade-off error if affect only a limited number of subsequent blocks and allow for self-recovery, but the system still experiences some error impact until that recovery occurs. The mode efficiency is constrained by its complex feedback mechanism and sequential processing requirements, making it particularly resource-intensive when handling long message sequences. So how about Aaron?
Okay, so thank you for asking. And now I will talk about the output feedback mode is OFB. So it's a cryptographic mode that converts a block cipher into a stream cipher and making it suitable for encrypting data streams in real time. And it will generate a key stream by encrypting an initialization vector, which is called IB, with the block cipher and repeatedly encrypting the output to produce subsequent key stream blocks. And the plaintext is XORed with the key stream to produce ciphertext, and the same process is used for decryption. However, there are some drawbacks. The IB is reused, the security of the system can be compromised, and limited error detection can make temporary harder to identify. And moreover, managing a secure and rendered IB has some computational overhead. So OFB is actually very efficient and secure, but proper IB management is critical to maintain its effectiveness. So next is about the compatibility table that we made throughout these 5 modes of operation. And you can see in this table, we can see some of them have the similarity in the their properties. So I think that's all for our Q&A. Thank you.